Okay, we can't use a u substitution here purely because we cannot express the derivative of either of these functions. So if x squared is f and cos x is g, if we take the derivative of either of these functions here, we can't express it in terms of the other function. So we're going to have to use integration by parts here. So we're going to let u be x squared, which means that du is 2x dx, and then dv will be everything else, which is cos x dx. When we integrate this, v will be sin x. When you differentiate v, the derivative of sin x is cos x. So when you integrate cos x, you get sin x. Okay, so we're now, in terms of u and v now, so this expression here, I call this f and g. We could have just as easily called it u and v. So what we have here, what we have is u dv, right? And we know that the integral of u dv equals uv minus the integral of v du. This is really just using the product rule of differentiation. So we have u dv, this expression is u dv. We now have uv, this is equal to uv minus the integral of v du. So uv will be x squared times sin x. So x squared sin x minus the integral of v du. So we'll have sin x, and du is 2x dx. Okay, so that gives us x squared sin x minus this 2 we're going to pull out of the integration, and we'll have x sin x dx. Now for this integral over here, we're going to have to use integration by parts again. Okay, so we're just going to write everything else down. Minus 2, open up square brackets. Now again, let's not confuse it with this u and v. I'm going to call it u and v again, but just bear in mind it's not this u and v that we've originally chosen. This is a new integration by parts. So I'm starting a new one. U equals x, du equals dx, and then dv is everything else. So it's going to be sin x dx. When we integrate that, we're going to get negative cos x. The derivative of negative cos is sine, so the integral of sine is negative cos. So again, we have uv using this formula. This over here is u dv. So we have uv, which is x times minus cos x. So it's minus x cos x minus the integral of v du. So it'll be minus cos x, and du is dx. So you can see by integrating again by parts, we've eliminated the second variable, the second function. We've just got a trigonometric function now. Okay, so that equals x squared sin x minus. We're not going to multiply anything out right now. We can keep everything as it is until we need to start simplifying. So we can pull this minus out. So we have plus the integral cos x dx, and that equals x squared sin x minus 2 times minus x cos x. The integral of cos x is sin x, and we need to add the integration constant as well. And now we can bring this 2 into those brackets. So x squared sin x plus 2x cos x minus 2 sin x minus 2 times the arbitrary constant is another arbitrary constant. And this is the answer. In this example, we're going to let u be tan to the minus 1 x, which is also arc tan x. The 2 over here, we're going to pull out because it's a constant. So dv is going to be everything else inside this integral, which is 1 over x squared dx du, so the derivative of 10 to the minus 1x will be 1 over 1 plus x squared dx. We call it the integral of 1 over 1 plus x squared dx is 10 to the minus 1 x. So we're going to pull the 2 out, and what we have is 1 over x squared times 10 to the minus 1 x dx. 10 to the minus 1x is u, and 1 over x squared times dx is dv. So what we have is 2 times u dv, and just recall that the integral of u dv equals uv minus the integral of v du. So that equals 2 times uv, so that'll be 10 to the minus 1x. We didn't integrate this, so v integrating 1 over x squared. 1 over x squared is x to the minus 2, so when you integrate that, we're going to add 1, so we'll have x to the minus 1, then we divide by minus 1. So v equals minus 1 over x. So uv will be minus 1 over x times 10 to the minus 1x. So minus 1 over x, 10 to the minus 1x. Then we subtract the integral v du. So minus 1 over x du, which is 1 over 1 plus x squared dx. So that equals 2 times minus 10 to the minus 1 x over x. Just going to pull this minus out. So it's plus the integral of 1 over x times 1 plus x squared dx. Now this expression here is a rational expression. So to determine this integral here, we're going to use partial fractions. So 1 over x times 1 plus x squared equals a over x plus bx plus c over 1 plus x squared. If you're unsure about partial fractions, there is a separate video that deals with partial fractions in detail, so refer to that if you need to. Getting a single fraction on the right will give us a times 1 plus x squared plus x times bx plus c. And that equals 1 over x times 1 plus x squared. We're going to equate the numerators now. So 1 equals a times 1 plus x squared plus x times bx plus c. And I'm just going to compare the coefficients. So if we take the coefficient of x squared, we have no x squared on the left, so we have 0. And then we'll have a plus b, so a equals minus b. We're now going to compare x. There's no x on the left, so we have 0. There's no x in the first term here, but we have x times c, so c will be 0, comparing the coefficients of x. And finally, we're going to compare the constant terms. So we have 1 on the left, and then we just have a, and there's no constant term there. So a equals 1, b equals -1, c equals 0. So we can write this as 2 times minus 10 to the minus 1x over x plus the integral of, now 1 over x times 1 plus x squared. We are going to write in this form here. So a is 1, so we will have 1 over x. B is minus 1. C is 0, so we can have a plus times a minus. and we've got an x there, so that'll be minus x over 1 plus x squared dx. We're just going to check the partial fractions before we continue, because if that is wrong, then everything else will be wrong. So 1 over x minus x over 1 plus x squared as a single fraction will be 1 plus x squared minus x squared, which is 1 over x times 1 plus x squared. Right, so checks out, it's correct. Okay, now we can split this integral up. So we have 2 times minus 10 to the minus 1x over x. Plus, we're going to split this integral up into two separate integrals. So the integral of 1 over x dx minus the integral of x over 1 plus x squared dx. That equals 2 times minus 10 to the minus 1x over x. The integral of 1 over x dx is just going to be ln x. And then over here, this last integral, we're going to use a u sub, right? Because if we let u be 1 plus x squared, the derivative of 1 plus x squared is 2x, and that x will then cancel with this x up here. So we are now going to let u equal 1 plus x squared. So du equals 2x dx. So we have minus the integral of x over u dx will be du over 2x, and this x will cancel that x. So we have 2 times minus 10 to the minus 1x over x plus ln x minus, we're going to pull this half out of the integral sign, have the integral of 1 over u du, and that equals 2 times minus 10 to the minus 1x over x plus ln x minus a half. The integral of 1 over u du is just ln u. And we're going to add the integration constant as well. And now u is 1 plus x squared, so we have 2 times minus 10 to the minus 1x over x plus ln x minus a half ln 1 plus x squared plus c. We're going to bring the 2 into these brackets now, so we have minus 2 over x 10 to the minus 1x plus 2 ln x minus 2 times a half is 1, so it's minus ln 1 plus x squared, and then 2 times an arbitrary constant is another arbitrary constant. We're going to clean this up because we've got two logarithms here. Minus 2 over x 10 to the minus 1x plus ln x squared minus ln 1 plus x squared plus c equals minus 2 over x 10 to the minus 1x. We have two logarithms here, so we're going to combine them. So we'll have ln x squared over 1 plus x squared plus c. And we don't really need the absolute value brackets because x squared is positive and 1 plus x squared is also always positive. So we don't need those absolute value brackets. So we just have ln x squared over 1 plus x squared, then plus c. Okay, so sec cubed x we are going to write as sec x times sec squared x. So sec x times sec squared x dx. Now I'm going to use the substitution u equals sec x. So du equals sec x tan x dx. dv is the rest of the integral, which is sec squared x dx. Sec x is u. So dv is sec squared x dx. And integrating sec squared x gives us tan x. So this equals uv, which is sec x tan x, minus v du, so that would be tan x times sec x tan x dx. So that equals sec x tan x minus the integral of sec x tan squared x dx. The left hand side here is the integral of sec cubed x. Okay, so we're just going to express the left hand side as a single integral. So we'll have sec x tan squared x plus sec x dx. And that's the integral of sec x times tan squared x plus 1 dx to the integral of sec x times tan squared x plus 1 is sec squared x, and sec x times sec squared x is sec cubed x. The reason I've done this is because this integral on the left appears on the right as well. The difference being the sign of the integral on the right. So we're going to move this integral over to the left and get 2 times the integral of sec x tan squared x dx. And at the same time, we're going to move this integral over to the right. So we're going to have sec x tan x minus the integral of sec x dx. Dividing through by 2 will give us the integral of sec x tan squared x dx equals a half sec x tan x minus a half the integral of sec x dx. So the left hand side we're going to write as the integral of sec x times sec squared x minus 1 dx. Instead of writing this all out again, I'm just going to go through the left hand side of the equation. So this will be the integral sec cubed x minus sec x dx, which we're going to write as two separate integrals, sec cubed x dx minus the integral sec x dx. So this we're going to put in place of the left hand side. Okay, the reason I left this integral on the right, integral of sec x alone, was because we got this term on the left as well. So the integral of sec cubed x dx, adding the integral of sec x dx on both sides of the equation, gives us a half sec x tan x minus a half the integral of sec x dx plus the integral of sec x dx. So the integral of sec cubed x dx equals a half sec x tan x minus a half of the integral sec x plus the integral sec x is just going to be plus a half the integral of sec x dx. And finally, we can find the integral of sec x. So we have a half sec x tan x plus a half. The integral of sec x is ln sec x plus tan x. Then we can add the constant. We'll add the constant of integration as well. So that is the expression for the integral of sec cubed x. This is also found on your table of integrals.